Transformer models like GPT can generate pages of coherent text, but there is a problem. The more text they generate, the more GPU memory they use. One of the main reasons is something called the KV cache. KV stands for key and value. Inside a transformer, every token is converted into three representations: a query, a key, and a value. The query represents the token the model is currently processing. The keys and values contain information about all the previous tokens. The model compares the current query with the previous keys to decide which parts of the context are important. It then uses the values to generate the next token. Without a KV cache, the model would have to recalculate the keys and values of every previous token each time it generates a new one. Imagine writing a sentence one word at a time, but before writing each new word, you have to reread and process the entire sentence from the beginning. That would be extremely slow. The KV cache solves this problem by saving the keys and values that were already calculated. When the model generates a new token, it only needs to calculate one new key and one new value. This makes generation much faster. But there is a trade-off. The cache becomes larger every time a new token is generated. It also needs to store information for every layer of the transformer and for every user request being processed. For example, in a 30 billion parameter model, the model itself may use around 60 gigabytes of memory, but with a large batch size, the KV cache can use around 180 gigabytes. That is 3 times more memory than the model itself. This is why long context windows are expensive. The KV cache makes AI generation faster, but the longer the conversation becomes, the more GPU memory the model needs.